Somewhere out there right now in the dark between the stars, there are black holes drifting alone, not sitting at the centers of galaxies, not feeding on companion stars in bright, violent pairs, just wandering, dark, silent, entirely invisible, coasting through the emptiness on long, slow paths. Having been traveling for millions of years and with millions more to go, there are probably 100 million of them in our galaxy alone. Perhaps many more. Nobody knows the number well because they are the hardest objects in existence to find. They give off no light. They have no companion to give them away. Most of them will never be detected by anyone. And they are moving. Not toward us and not with any purpose, but moving. As everything in the galaxy moves at tens of kilometers every second, along their own paths around the galactic center. Tonight we are going to ask what would happen if one of them came here. Not to swallow the sun, which is a different question, simply to pass through, to come coasting quietly into our solar system, cross it, and continue on into the dark on the other side. And the answer is one of the more interesting things in astronomy, because the damage would be done almost entirely by something falling apart rather than by anything being destroyed. Nothing would be eaten, nothing would explode, and yet the solar system might never be the same again. But before we go a step further, let me ask you something, softly, because it matters more than you might think. If these quiet journeys through the strange corners of our universe help you set down the weight of your day and find your way toward rest, then please take just a moment, right now, before you settle any deeper into the warm. And subscribe. It is one small tap, but it means the next of these will find its way back to you on some future restless night when sleep is a long way off and you need somewhere gentle to put your mind. And it helps, more than you could possibly know, to keep these stories being made, for you and for everybody else out there in the dark tonight looking for a little peace. So if you would, subscribe and stay with me, night after night, as we wander together through the great slow mysteries of the universe. And tell me, if you will, from wherever you happen to be resting tonight, in whatever quiet corner of the world is holding you, where are you listening from? And what hour has it reached where you are? Leave it in the comments below. It is a lovely thing to see all the places and all the hours gathered there together, all of us drifting off beneath the same turning sky, in 100 different countries and 100 different hours, all of us here in the dark at once. And now let your shoulders come down and let your breathing slow, and let the whole weight of your day loosen and fall away. Come with me out to the very edge of the solar system, further out than most people ever picture, and let us watch something arrive. Let us begin with where these wandering black holes come from, because they are not an exotic hypothetical. They are a well-founded expectation, and we have recently found one. A black hole is what is left when a very massive star dies. The star runs out of fuel, its core collapses, and the outer layers are blasted away in an enormous explosion. And that explosion is very rarely perfectly symmetrical, which means the remnant left behind gets a kick. The debris flies off slightly unevenly, and by the ordinary rule that every push has an equal push in the other direction, the newborn black hole is shoved in the opposite direction, sometimes very hard indeed. Speeds of tens or even hundreds of kilometers per second are possible. So a great many black holes do not stay where they were born. They are launched out of their birthplaces, out of the star clusters and nebulae where they formed, and sent off across the galaxy on their own. And there is a second way to end up wandering, which is to be evicted. Most massive stars are born in pairs or in larger groups, and many of them are born in dense clusters where thousands of stars are packed relatively close together. In a crowded place like that, gravitational encounters happen constantly, and they tend to have a particular result. When three objects interact, the lightest is usually flung away and the remaining two draw closer together. Over millions of years, that process ejects a steady stream of objects from every cluster, and the black holes among them go out with the rest. Some are thrown out gently, some are thrown out at enormous speed. There are even objects known that are traveling fast enough to leave the galaxy altogether, having been flung out by a close encounter with the enormous black hole at the galactic center. Those will coast off into intergalactic space and travel for billions of years through emptiness far deeper than anything inside a galaxy. So the population of wanderers is being continually topped up, by explosions that kick and by crowds that evict, and once something is out there, it essentially never comes back. And once they are out there, they simply keep going. There is essentially nothing to slow them down. Space is empty enough that they can coast for hundreds of millions of years without encountering anything at all. They also have no reason to shine. A black hole with nothing falling into it produces no light. If it drifts through a region with a little gas, it might glow very faintly as it swallows some, but in the vast emptiness between stars, there is almost nothing to eat. So most of them are entirely dark. So the galaxy contains a large population of invisible, fast-moving, isolated objects, each one a few times the mass of the Sun, with no way to see any of them directly. For a long time, this was a theoretical expectation with no confirmed examples. Then a few years ago, one was found. And the way it was found is quite lovely, so let me tell you about it, because it is one of the more elegant tricks in astronomy. Mass bends light. That is the discovery we spoke about in the series on gravity, and it has a practical use. If a massive object passes directly between us and a more distant star, its gravity acts as a lens. The starlight is bent around it and focused toward us, and the star appears to brighten over days or weeks, and then fade again as the alignment passes. The shape of that brightening curve tells you about the object doing the bending, its mass roughly, and something about its motion. And crucially, the lensing object does not need to emit any light at all. It is detected purely by what its gravity does to something behind it, which makes it the perfect method for finding things that are invisible by nature. So astronomers run long surveys, watching many millions of stars at once, night after night for years, waiting for one of them to brighten in that characteristic way. Most such events turn out to be ordinary faint stars passing in front of more distant ones. But some are more interesting. And in one case, after years of careful observation and a good deal of argument about the interpretation, a lensing event was traced to an object of several solar masses that emitted no light whatsoever. An isolated stellar mass black hole, drifting alone some 5,000 light-years away, discovered purely by the way it briefly magnified a star behind it. That was the first confirmed wandering black hole, and there will be many more because the surveys are getting better. It took an extraordinary amount of work to be sure of it, incidentally, and that is worth mentioning because it shows what this kind of astronomy actually costs. The brightening itself lasted for months, but the crucial evidence was not the brightening at all. It was that the star behind appeared to shift very slightly in position while it was being lensed, because the light was arriving along a bent path rather than a straight one. That shift was a matter of milliarcseconds, an angle so small it is like measuring the width of a coin from thousands of kilometers away. Measuring that required the finest telescope available over a period of 6 years, returning to the same star again and again as the event unfolded and faded. And then 2 independent teams analyzed the data and initially disagreed about the mass of the object, and it took further years and additional observations to settle the question. So the discovery of the first wandering black hole was not a moment. It was the better part of a decade of extremely careful measurement of a single faint star by people who had to argue with each other before they were confident. That is what most real astronomy looks like, not a sudden sighting. Years of patience about one small thing. Rest a moment on that because it is a remarkable thing to have done. Somebody found an invisible object in the dark, thousands of light years away, by noticing that a star behind it got slightly brighter for a few weeks and then went back to normal. That is the whole method. Patience and a very careful eye on a great many stars at once. Now let us bring one here. The first thing to establish is that we would know about it a very long time in advance. This is not a scenario where something appears without warning. The distances involved are so enormous and the speed so modest by comparison that any approach would take an extremely long time and would be visible for most of it. An object 4 light-years away, heading directly toward us at a typical galactic speed of around 50 kilometers per second, would take something in the region of 25,000 years to arrive. 25,000 years. That is longer than the whole of recorded history several times over. That is longer than agriculture has existed, and we would not merely detect it at the last moment. Something that massive approaching would announce itself in several ways. It would lens the light of stars behind it repeatedly as it moved across the sky, and we watch for exactly that. It would perturb the paths of distant objects long before it arrived. Astronomers who track the outer solar system would notice the disturbance and would be extremely interested. So the realistic picture involves not panic, but an enormous, slow, well-understood approach studied by hundreds of generations of astronomers, most of whom would be born and die while it was still an abstract point of interest very far away. And I want to dwell on that a little, because it is such an unusual shape for a threat to have, and it says something about how astronomy actually works. Imagine the sequence. At some point, a survey notices a lensing event that does not fit the usual pattern, and after some years of argument, the conclusion is reached that there is a dark, massive object in a particular direction, at a particular distance, moving in a particular way. That is a paper, and a modest amount of interest, and then the field moves on. Centuries later, better instruments refine the trajectory, and somebody notices that the path passes uncomfortably close to us in about 20,000 years. That is a more interesting paper. It is discussed. It is nobody's practical problem. Thousands of years after that, with the object still further away than the nearest star, the outer solar system begins to show the first faint disturbances, and the predictions become precise enough to matter. And still nothing is happening, and nothing will happen for many more thousands of years. At every point in that story, the people involved would know a great deal, would be able to do nothing, and would not be personally affected. The knowledge would be handed down through hundreds of generations, across the rise and fall of every language and country that existed during it, arriving eventually at people who would have no cultural connection to those who first noticed. It is an oddly gentle kind of catastrophe, entirely predictable, entirely unavoidable, and entirely somebody else's problem for a very long time. Now, what happens when it gets here depends entirely on how close it comes. And I want to walk through 3 different distances, because the outcomes are quite different, and the first one is not what people expect. Let us start with a distant pass. Suppose the black hole comes no closer than, say, 1/10 of a light year. That sounds close in galactic terms, and it is enormously far in local terms. It would be more than 600 times further away than our outermost planet. At that distance, it would do nothing whatsoever to the planets. Nothing measurable. The orbits of the Earth and its neighbors would be entirely unaffected. It would pass and go, and if you were standing outside on the night it went by, you would see nothing at all. But it would do something, and this is where the solar system turns out to be much bigger than most people picture. Because the planets are not the outer edge of anything. Far beyond them, extending outward for something like a light year or more in every direction, there is an enormous spherical cloud of icy bodies left over from the formation of the solar system. Trillions of them, chunks of ice and rock, ranging from a few kilometers across to much larger, drifting in the deep cold, so far out that the sun is merely the brightest star in their sky. I want to give you a sense of the scale here, because almost nobody pictures the solar system correctly, and the true shape of it matters enormously for tonight. When people imagine the solar system, they imagine the planets, 8 of them, in neat orbits, with the outermost at some enormous distance. But the planets occupy only the tiniest core of the thing. If the solar system were a city, the planets would all be inside a single house near the middle. Beyond the outermost planet, there is a broad belt of icy bodies, and beyond that, the space thins out, and then, far further, at distances thousands of times greater than the outermost planet, that great spherical cloud begins. And it extends outward and outward, for perhaps a quarter or a half or even a full light year, which means the sun's territory nearly reaches the territory of the next star along. The 2 systems are not separated by a great gulf of nothing. Their outermost, loosest, coldest belongings are almost touching. An object out there takes millions of years to complete a single orbit. It moves at the pace of a slow walk. It has been out there since the solar system formed 4.5 billion years ago, and has gone around perhaps a few hundred times in all that history. And it is held so loosely that the passing of a star several light years away is enough to disturb it. This happens regularly, incidentally. Stars do pass within a light year or 2 of us every few 100,000 years, and every one of those passages stirs that outer cloud a little. They are held very loosely. Out there, the sun's grip is extremely weak, and those objects are creeping along their enormous orbits at walking pace, taking millions of years to go around once. And a passing black hole, even at 1/10 of a light year, would disturb that cloud considerably. It would not drag the objects away, it would simply nudge them. And a nudge is all it takes, because they are so loosely held. Some would be knocked out of the solar system entirely. And some, crucially, would be nudged onto paths that carry them inward, which means that in the millions of years following the encounter, the inner solar system would experience a shower of comets, not all at once since it takes them an extremely long time to fall that far. But over an extended period, the number of comets arriving in the region of the planets would rise substantially, perhaps by a large factor. And a raised comet rate over millions of years means a raised rate of impacts on the planets, including this one. That is the actual danger from a distant pass, not the black hole itself, which would come nowhere near us and would be entirely invisible from here. Something it nudged, arriving quietly, 1,000,000 years later. Rest a moment on that, because it is such an odd and indirect kind of harm. A dark object passes a very long way away, touching nothing, and the consequence arrives 50,000 generations later as a bright object in the sky. Now let us bring it closer. Suppose it passes through the outer solar system, somewhere in the region of the outer planets. Now things become serious, and the mechanism is worth understanding, because it is not what most people imagine. The black hole would not eat anything. That is worth saying plainly. Its horizon might be 60 kilometers across and the solar system is billions of kilometers wide. The chance of it directly hitting any particular object is essentially zero. It would sail straight through the middle of everything and touch nothing at all. The damage would be done entirely by gravity, and above all, by the way, gravity ruins a delicate arrangement. The solar system is stable because of something very simple. There is one dominant mass at the center, and everything else is far less massive and reasonably far apart. Each planet essentially only feels the sun, with small tugs from its neighbors that average out over long periods. That arrangement has held for 4.5 billion years, and it will hold for billions more because nothing ever comes to disturb it. Now introduce a second object of comparable or greater mass passing through. Suddenly every planet is being pulled in two directions at once by two large masses in a changing configuration. And that kind of arrangement is not stable. Systems with two large masses and a small one behave chaotically. The small object's path becomes extremely sensitive to exactly where everything was at the start, and small differences grow rapidly, and the result cannot be predicted in detail even in principle. That word chaotic is worth being precise about, because it has a technical meaning here that is more interesting than the everyday one. It does not mean random, and it does not mean lawless. The physics is perfectly ordinary and completely deterministic. If you knew the positions and velocities of everything with infinite precision, you could calculate exactly what would happen. What it means is that the outcome depends on the starting conditions so sensitively that any uncertainty at all, no matter how tiny, grows until it swamps the prediction. Shift the Earth's starting position by a single meter out of 150 million kilometers, and the eventual outcome could be completely different. Ejection instead of survival, or the reverse. This is the same property that makes weather unpredictable beyond a couple of weeks, and it is a genuine feature of the physics rather than a shortcoming of our calculations. Some systems simply do not permit long-term prediction, however good your instruments are. So the honest answer to what would happen to the Earth is not a number, it is a set of probabilities. This many % chance of ejection, this many of a badly disrupted orbit, this many of surviving more or less intact, depending on the details of the encounter. Astronomers do run these simulations thousands of times over with slightly varied starting conditions, and what comes out is a distribution of outcomes rather than a prediction. So the outcome for any given planet would be effectively random. Not random in the sense of unphysical, but random in the sense that the tiniest difference in the timing of the encounter would produce a completely different result. Some planets would be flung out of the solar system entirely, given enough energy to escape the sun's grip, and sent off into interstellar space on their own. Some would be thrown into wildly elongated orbits, swinging in close to the sun and then far out into the cold, over and over, with catastrophic consequences for anything living on them. Some would be captured by the black hole and dragged away with it, becoming part of its entourage as it continued on its journey. And some would be barely affected at all if the geometry happened to favor them. There is no way to say which would happen to us. It would depend on where the Earth was in its orbit on the day of closest approach, which is a matter of pure chance. Now let us take the outcome that people find most haunting, because it is also the one that connects to something real and rather wonderful. Suppose the Earth were ejected. The process itself would be undramatic, which is the strange part. There would be no violence. The Earth would simply be given some extra speed by the encounter and would begin traveling on a path that does not come back. For the first months, almost nothing would seem wrong. The sun would be in the sky. The seasons would be a bit strange. Astronomers would have worked out the trajectory and would know, but nothing would look different to anyone outside. Then, over years, the sun would begin to shrink. That is the detail I find most affecting about this scenario. It would not go out, it would recede. Each year it would be a little smaller in the sky, a little dimmer, a little further away. Someone born in the first year of the journey would grow up watching the sun get smaller. Let me lay that out a little more carefully, because the timescale is slower and stranger than people expect. In the first year or two, the change would be barely noticeable to the eye. The sun would be measurably smaller to an instrument, and the winters would be worse, and the growing seasons would be shorter, and everyone would know why. But you could still go outside and stand in sunlight. By perhaps the 5th year, the light would be visibly weaker. The sun would be noticeably smaller in the sky, and the world would be dimmer at midday than it had ever been, and cold everywhere. Within a decade or two, the oceans would be freezing over, and the sun would be little more than an extremely bright point, too small to show a disk, casting shadows but giving no warmth. Within a century, it would be simply the brightest star in the sky, brighter than anything else up there, but a star, indistinguishable in kind from the others, just closer. And within a few thousand years, it would have faded into the background entirely. Someone standing on the surface of that frozen world, if anyone could, would look up at a sky full of stars and would not be able to tell which one it had been without consulting a chart. There is something about that slow retreat that I find far more haunting than an abrupt ending. Not a light going out, a light going away steadily over generations while people watched. It would take years for the temperature to become truly serious, and decades for the sun to become simply a very bright star, and centuries for it to become an ordinary star among the others, at which point there would be no way to pick it out of the sky except by knowing where to look. And then the Earth would be a rogue planet, a world with no star, traveling alone through interstellar space at some tens of kilometers per second, in permanent darkness, forever. And here is the thing that makes this more than a thought experiment. There are a great many of those out there. Rogue planets are real, and they are common. Worlds that were formed around stars and then ejected by exactly this sort of gravitational disruption, or that formed alone and never had a star at all, drifting through the galaxy in the dark. We have found them. They are very hard to detect for obvious reasons, but the same lensing trick works, and surveys have found free-floating objects of planetary mass with no host star, and the estimates for how many there are keep rising. Some analyses suggest that rogue planets may be as numerous as stars in our galaxy. Some suggest they may outnumber stars, perhaps by a great deal, which means something rather startling. It means that the ordinary condition of a planet in this galaxy may well be to have no sun at all. The sunlit worlds may be the minority. There may be tens of billions of dark, silent, wandering worlds out there in the space between the stars, with oceans frozen solid and atmospheres lying on the ground as snow, drifting in the dark. And they may be the normal case, and we may be the exception. And there is a further thought about those worlds that is worth a moment, because it is not entirely bleak. A rogue planet is not necessarily dead. We know that a world can stay warm inside without any help from a star. The Earth's interior heat comes largely from radioactive decay in the rock, and that process has nothing to do with sunlight and would continue unchanged for billions of years, no matter where the planet went, which means an ejected Earth would retain a hot interior and volcanic activity, and heat flowing steadily up from below. It would keep a liquid ocean beneath its ice for a very long time, possibly for billions of years, warmed from underneath. And we already know that ecosystems can run on that heat alone. At the bottom of our own oceans, there are entire communities of living things clustered around volcanic vents in permanent darkness, built entirely on chemistry rather than light. There is also a vast amount of microbial life living kilometers down inside the rock of this planet, in the pores and cracks, most of it entirely independent of the sun. None of that would stop. So the picture of a rogue planet is not necessarily a sterile frozen rock. It might be a world with a thick ice shell and a dark, warm ocean beneath it, going nowhere for eternity, with things living in it. And if rogue planets really do outnumber stars, then it is at least possible that most of the life in this galaxy, if there is any, exists in exactly that condition. In the dark, under ice, on worlds with no sun, drifting between the stars, with no way of ever knowing that there is anything else. That is a strange thought to lie in the dark with, and I mean it kindly. It suggests that light and warmth from a sky might be the unusual arrangement, and that we may be the ones in the odd situation, looking up at a bright star every morning and thinking it normal. Rest a moment on that, because I find it one of the strangest facts in modern astronomy. When you look up at the night sky, the darkness between the stars is not empty. It is quite possibly full of worlds, silent ones that nobody will ever see, going nowhere in particular, forever. And some of them, almost certainly, were once warm, with sunlit surfaces, before something came past. Now there is a happier variant of the ejection scenario, and it is worth mentioning because it is entirely possible and rather charming. The Earth might not be ejected into empty space. It might be captured. If the geometry were right, the Earth could be pulled away from the Sun and into orbit around the passing black hole, carried off as a companion. And that would be a very strange world indeed. A planet orbiting a black hole in permanent darkness, with no light in the sky at all, except the stars. Would it be habitable? Almost certainly not in the long term, for the same reasons we discussed. But there is an interesting wrinkle. A black hole with any material falling into it produces radiation, and in principle, a planet at the right distance from a modestly feeding black hole could receive real energy from that. It would not be pleasant, and the radiation would be of the wrong kinds, and the arrangement would be unstable. But the idea of a world warmed by the light of matter falling into a black hole is not physically absurd, and it has been considered seriously enough to appear in the scientific literature. And the sky from such a world would be one of the strangest views in the universe. There would be no sun, but there would be in one direction a region of sky where the stars were bent into rings and arcs around a perfectly black circle, distorted by the curvature, with the same star sometimes appearing in two places at once on either side of the darkness. And if the black hole were feeding even slightly, there would be a thin, bright ring around that darkness glowing, the light of matter making its last journey inward, a world with no sunrise, going around a hole in the sky, with a ring of light in it. That is not a poem. It is a description of an arrangement that the laws of physics permit, and that may well exist somewhere out there tonight, going around and around in the dark, with nobody to see it. Now let us take the third and closest case, briefly, and then move to the reassurance. Suppose the black hole passed through the inner solar system. At that point, the disruption would be immediate and total. Planetary orbits would be destroyed within a single passage. The Earth could be ejected, captured, thrown into the Sun, or in the extremely unlikely event of a direct alignment, consumed. And even that last case would not look like being swallowed. The Earth would be torn apart by tidal forces well before reaching the horizon, drawn out into a stream of rock and iron, which would then form a small hot disk and glow briefly and be gone. But this is where the numbers become important, and they are extremely comforting. Space is empty. That is the central fact of astronomy, and it is almost impossible to convey properly, so let me try with a picture. Shrink the sun to the size of a grain of sand and place it on a table. On that scale, where is the nearest star? About 6 kilometers away. Another grain of sand, 6 kilometers off, with absolutely nothing in between. That is the actual density of matter in our part of the galaxy. Grains of sand, several kilometers apart, drifting slowly past one another. and the black holes among them are rarer still, perhaps one for every 1,000 or so stars. For one to pass through our solar system, it would have to hit a target that, on that scale, is a fraction of a millimeter across, from 6 kilometers away, while both objects are drifting slowly and neither is aiming. The calculated odds are correspondingly tiny. The expected time between such encounters, for any given star, runs into the many billions of years, which is to say longer than the universe has existed, and in most estimates far longer. The Sun has been going around the galaxy for 4.5 billion years, about 20 times, passing through crowded regions and quiet ones, and nothing of the kind has happened. The stability of the planetary orbits, which we can trace back a very long way in the geological record, is itself evidence that nothing has come close in an extremely long time. So the honest assessment is that this will not happen. Not in your lifetime. Not in the lifetime of our species, and quite possibly not in the remaining lifetime of the Sun. Rest there a moment and let that settle properly, because it is the ground under everything else we have said. There is a reason our solar system has been undisturbed for 4.5 billion years, and the reason is not luck. It is that the galaxy is almost entirely empty, and encounters between stars are so rare that they essentially do not happen to any given star ever. That emptiness is the thing that made all of this possible. It is why the Earth has had a stable orbit for long enough for life to develop, and then for complex life, and then for us. If stars were packed closer together, close encounters would be common, planetary systems would be regularly disrupted, and there would probably be far fewer places in the universe where anything could sit still for 4 billion years and get on with becoming complicated. We live in a very empty place. That emptiness feels lonely if you think about it one way, and it is the reason we exist if you think about it another. And it is worth being precise about how quiet our particular neighborhood has been, because the record is quite good. The orbits of the planets can be traced backward with considerable confidence for a very long time, and there are also physical records. Layers in ancient rock preserve the rhythms of the seasons and the tides going back hundreds of millions of years, and those rhythms depend on the shape of the Earth's orbit and on the length of the day. If anything had passed close enough to disturb the solar system in that period, it would show. It does not show. The orbits have been steady. The year has been the same length within the small variations we expect from the ordinary tugging of the planets on each other. The seasons have come and gone on schedule for as far back as the rock's record. And that steadiness is itself the evidence. 4.5 billion years of nothing happening is a strong statement about how often things happen. So when I say that this will not occur, I am not offering reassurance for its own sake. I am reporting what the geological record says. Whatever might be possible in principle, in practice, nothing has come close enough to matter in the entire history of this planet, through 20 complete orbits of the galaxy, and there is no reason to expect the next few billion years to be different. Now, before we finish, I want to give you one more thing, because it is the detail I find most interesting about tonight's question, and I have saved it. What would you actually see if one passed nearby? Not close enough to destroy anything. Say it passed through the outer solar system, several billion kilometers away on a quiet night, and you happen to be outside looking in the right direction. You would see almost nothing, and what little you would see would be extraordinary. There would be no dark shape. The object would be far too small to appear as anything at that distance, and there would be no glow if it were not feeding. But there would be a distortion. The intense curvature of space around it bends the light passing nearby, which means that stars behind it would be displaced from their proper positions and stretched, and in some cases doubled. You would see a small region of sky where the stars were wrong, smeared into arcs, duplicated on either side of an invisible center. A patch of the night that looked as though it were being viewed through a flaw in a window pane. And that patch would move, slowly, across the sky over the years, dragging the distortion with it, while the stars behind it slid into position and were briefly warped and then released. That is what a black hole passing through the neighborhood would look like. Not a monster, not a hole. A wandering patch of bent starlight drifting silently across the constellations, and if you did not know what it was, you would think there was something wrong with your eyes. And it would be silent, of course, entirely. There is no air out there to carry anything, and nothing about the process makes noise in any case. The most destructive event in the history of the solar system would happen without a sound and would look like a smudge in the stars. The planets would go on looking exactly as they always do for years, while their orbits were quietly being ruined. Nothing would appear different from the ground for a very long time. The changes would be measured by astronomers before they were noticed by anybody else, and there would be a long, strange period in which everything looked completely normal and everyone knew that it was not. Rest a moment with that image, because it is one of the eeriest and most beautiful things I know of, and nobody has ever seen it, and almost certainly nobody ever will. And so, let us come back. Nothing is coming. That is the plain truth of it, and it deserves to be said clearly at the end of an evening spent imagining otherwise. The galaxy is enormous and empty and slow. The nearest black hole is over 1,000 light-years away and is not moving toward us. The nearest star of any kind is 4 light-years off and has been in roughly the same relationship to us for a very long time. There is nothing on any approach path. We have looked and we continue to look with instruments designed for exactly that purpose, and there is nothing. The solar system you are lying in tonight has been stable for 4.5 billion years. Every orbit in it is exactly where it was last year, and the year before, and where it will be next year, and in 1,000 years, and in 1,000,000. The Earth will be going around at 18.5 kilometers a second tonight, and tomorrow night and every night, without any variation you could measure. That clockwork is not fragile. It is one of the steadiest things in existence, and it has run without interruption for longer than there has been life on this planet. So let it rest now. Let the wandering black holes go back into the deep dark where they belong, coasting quietly along their own paths, thousands of light years away, having nothing to do with us and no interest in coming closer. They have been out there the whole time. They were out there last night, and the night before, and every night of your life, and nothing about tonight is any different. That is worth saying plainly, because it is the honest comfort in all of this. Nothing we talked about tonight is new. Every one of those objects was already there when you woke up this morning, and when you were born, and when the pyramids were built. The universe has not changed this evening. Only your picture of it has slightly, and a picture is a safe thing to carry. Let the rogue planets drift on too, all those silent frozen worlds out in the space between the stars, going around nothing, in the dark, in enormous numbers. They are strange and rather sad to think about, and they are also very far away, and they do not need anything from anybody. And if it helps, think of them warm inside. Most of them probably are. Frozen on the outside and quietly warm underneath. Going nowhere in particular for billions of years, perfectly content in the way that only something with no opinions can be. There is nothing here you need to carry, nothing to watch for, nothing to guard against. The sky above your roof tonight is the same sky that was there yesterday, containing the same stars in the same places, with nothing new in it and nothing approaching. You are on a warm world in a stable orbit around an ordinary star, in one of the emptiest and quietest regions imaginable, with several billion kilometers of nothing at all in every direction, between you and anything that could possibly matter. The floor is holding, the air is staying, the orbit is exactly where it should be, as it has been for 4.5 billion years, as it will be in the morning. So let your breathing slow, and let the whole strange business drift away, out past the roof and the moon and the planets, out into the enormous quiet dark where it lives, and let it stay there, unbothered and unbothering, while you rest. Sleep now. Nothing is coming. Nothing has ever come. The solar system will keep turning tonight exactly as it always does, quietly and reliably, without needing any attention from you at all, and it will still be turning in perfect order when the morning arrives.